Thank you. So, we're going to talk today about how to make React Native mean and lean, but we might as well call this talk so you want to optimize your framework, app, site, module, library, something. Because while I'll be telling the story of React Native and how we made it performant, I believe the lessons from today's talk could be applied to just about any other system. So, let's start from the beginning. My name is Dan. I used to live here in Israel, and then I moved around a year ago to London to work at Facebook at making React Native more performant and faster. I'm very excited to be here today and tell you the story. Actually, I'm very excited. I had to make sure with the organizers several times that they actually want me to come here and talk about what we do. But they said yes, so you're stuck with me here for the next 30 minutes. So let's get started. So before I'm going to talk about how to make React Native fast and lean, I'm going to talk about React.js for the 2 or 3 people in the room that don't know it yet. I'm going to introduce React Native then. We're going to talk a little bit how it works, and then you'll have everything you need to know for us to be able to talk performance. All right, so our story begins around 2 years ago, where at Facebook we understood we realized we needed a better JavaScript framework to handle our vast and very complex UI. So we came up with React.js, or as some of you may know it, React. React is easy to write and fast to write. It's declarative, which makes it very easy to debug and to scale, and it's also very efficient in the way it handles its DOM. So for instance, this code snippet in React generates or renders a simple to-do list. As you can see, JSX elements are intertwined inside the JavaScript code, which makes it very fast to write and to find bugs and to fix them. So this code will generate this to-do list for my visit here in Tel Aviv. And whenever I want to change some part of the DOM, React will realize what part of the DOM is changed and will change only this one without touching the rest of the DOM, making it very efficient. React.js is very fast, very efficient, and as we said, it's very nice to write. And I guess it's no surprise that it's all over Facebook.com and in many other websites today. So we had React.js, which we were very happy about, and it was performing well, and we had all the tools. And then our mobile developers at Facebook started asking, how could they get all of these benefits? Well, this is how React Native was born. React Native is React.js's mobile incarnation. It uses JavaScript to write in code, CSS-like styling, but it is not a web app framework. React Native apps are actual native apps. They use native views, which means they're quick, they're responsive, it doesn't require network to work, and it can use all of the phone's capabilities. React Native is used today in hundreds of apps, including our most prominent apps, and with 33,000 stars on GitHub, it's the number 16 project in all of GitHub, and it has a vibrant community around it. So what makes React Native so good? Why is it so popular? Well, let me tell you. First, it uses web technologies, as I just mentioned. Code is written in JavaScript. Styling is done in a CSS-like way. It uses Flexbox for layout, and it's based on React.js. So all of the good things we mentioned about React.js apply here too. React Native changes, when you write them, they reflect immediately in your simulator or in your device without having to rebuild the app, which I think every mobile developer in the room here will agree is a great thing. React Native is learn once, write anywhere, meaning that once you know how to write code in React Native, you can easily write apps for iOS as well as for Android, and as of lately, Windows too. And lastly, it supports the theoretical possibility of shipping your changes immediately to the users with an over-the-air update. So I can talk a lot about how cool React Native is, but I think it will be better to show it to you. So I'm going to use the F8 app. To people here in the room who doesn't know, F8 is Facebook's yearly conference, kind of like Google's I/O or Apple's WWDC. And for this year's conference, we wrote the F8 app all in React Native. We also publish its source, and it's available for you as an open source online. So I've took the F8 app, it's right here, and notice how smoothly it runs, even in the simulator. When I open a session and I want to see details, notice how fast the session details load from inside the app. On the left is the source code for some of the features we see here. For instance, the F8 session cell. Now, I'm a developer, not a not a designer, but I think bold text for the session titles may look a bit better. So I'm going to uncomment this line, and notice how I just save the file in my editor, and look at the simulator, and the changes reflect immediately. Yeah, I agree with you guys. Usually, you would have to rebuild it, but again, this is not a web view. The changes actually reflected, and the actual UI labels there were updated. I also think that 12 is not big enough for the location text. How about 32? Yeah, I'm definitely a developer, not a designer. I want to show you one more thing. So these are styling, which is, again, pretty nice. But let's say we want to greet someone when he looks at a session details. Let's say we want to wish him a happy session or an enjoyable one. So I'm going to uncomment this very simple line here, which is, as most of you will recognize, a simple alert box, which says enjoy and session.title. I just know this object, but the source is there. You can have a look at it. And I'm going to save it. That's about it. All right, the change is reflected. And notice what happens now when I click on a session. I immediately get the alert. But what's even more cool is this alert is not a web alert. This is actually iOS's UI alert view, which React Native turned your alert, your JavaScript alert, into native alert. And it does it for every other view. Cool, so I hope you enjoyed this demo and it brought home how cool React Native is. So this was the F8 app, but React Native is also being used in other Facebook apps like Groups, on Navel's Protect for Android, and even in our main Facebook app. So how does it work? Quite simple. React Native contains native modules that are written in the platform's native language, Objective-C for iOS, Java for Android, etc. You write your JavaScript code. And we need something in the middle. What turns your JavaScript code into native views? Well, this will be the React Native bridge. Native events, like touches and swipes, are received on the native side. They are then sent through the bridge to your JavaScript code, where you evaluate them, exactly like we just did. Then your JavaScript code runs, and UI changes are being sent back through the bridge to the native side, where they are reflected. To be honest, we need to add one more component right there. Between the JavaScript code and the bridge, there is something called JavaScript Virtual Machine. Some of you know it. It's the system that actually reads and executes your JavaScript code. And we'll talk about it in a second. So by now, you know React Native pretty well, and I know this clicker pretty well too now, for us to be able to talk performance. So before we get to talk about performance, I want to talk about why it matters. Well, we in the React Native team want to bring the best developer experience to the developers, and I think we're doing that. But what about the user's experience? We don't want the users to sacrifice because the developer had a good time developing the app. We want to bring the best experience we can to the users too. As I'm sure some of you know, performance is key to users' engagement and satisfaction from an app. And for those of you who don't know, I have some easy to find excerpts here. For instance, from web performance today, mobile stress, slow web pages lead to increased user frustration and lower engagement. I'm sure it doesn't surprise any of you. Just like the next statement, that IT and end users disagree on what makes a good desktop experience. But that's not what I want to show you. I think everybody knows that. From this article, more than 4 in 5 of end users surveyed ranked good performance as the top factor impacting their great user experience. These are your users. This is what they're thinking. The links for the articles are here in the slideshow. So we wanted to make React Native very performant. The case is even stronger in hybrid apps. Hybrid apps are apps that are not written in React Native, but have some features in them written in React Native. For instance, our main Facebook app is not written in React Native, but some of the features there are, like the events dashboard. When you click on the hamburger menu, sorry designers, and you enter the events dashboard, this thing is implemented in React Native for some of our users. A user expects a slight delay when he or she launches an app, but he does not expect a delay when he clicks a button inside of your app. And if you want to enable this hybrid apps thing, we need to make sure React Native is fast enough for the user not to feel the experience is broken. Lastly, we also need to support low-end devices. Not all of our users are using iPhone 6s, right, or the latest Android device. So React Native has to be performant. So how do we do that? First, we start by setting a goal. When we get an app or a feature we want to improve, we start by setting a goal. Our metrics include app startup time, which is the time from the moment the user touched the app icon until it's ready and responsive and ready to be interacted with. Or it could be memory usage, because you know that websites and apps that use a lot of memory are heavy. They feel laggy. And in our case, they're at the risk of being killed by the operation system. And lastly, we aim at responsiveness. We want the app to feel snappy, fast. We want the user to enjoy using it. There are a lot of ways of measuring that. You could, for instance, measure what percent of time you spend under 60 frames per second. These are some of the metrics we use. You may have other ones like data usage, but just find your goal, find your metrics. And once you have your metrics, you need to set a goal. And how do you do that? Well, one rule I can give you, which is pretty simple, is the 20% rule, which means that for the user, researchers found that performance needs to improve by at least 20% before your users start noticing it. So if you want to improve your app startup time, take the current time and aim to improve it by at least 20%. But I believe you can do better than that. Or if you need other help on setting the goal, there's a great blog post by Microsoft that has recommended times for every interaction and how long it should be. I recommend checking it out. All right, so we have our goals. We know what we're aiming for. What do we do next? Next, we measure. We build tests that don't test correctness, don't make sure that the app doesn't crash, but rather it measures the memory usage, the startup time, it measures pretty much everything. And then we run them a lot. What's a lot? How often do we run the test? Well, we have two different paradigms for that. One of them is for some changes, and I'll stop here to tell you a story. Some programming languages, like C++, have the ability to remove code that is not meant for production. For instance, debugging code, or code that is meant for other platforms than the one you're shipping to. JavaScript, on the other hand, doesn't have this. So the cool refresh feature I just showed you when we played with React Native app, this will ship to production too. But this makes our package a bit big, and it makes loading time a bit slower. So an engineer on my team had an idea of maybe teaching Babel, which goes through our source code every time before we ship it, maybe teach Babel to remove debugging code, or remove code that is not meant for this platform from the JavaScript bundle and package. And he did it, but before we could ship it, we had to make sure that this actually improves performance. So we sent it to a system that we call ScanLab that checks this change set against the latest stable one. And we saw that it was quite a significant improvement. I'm not sure this is the number for this change, but it was pretty close to this. And this system is a system we use pretty often. Every time we have a new performance feature idea, we send it to the system, which runs this change set tens of times. It runs the stable tens of times, and then it compares the performance results, and it tells us if we actually made an improvement, or rather, if the change set we're going to ship going to hurt performance. You could do the same. Another system we have is a system that periodically runs the test on the latest stable for every hundreds of commits. When we notice a big change, we start on triaging and finding the exactly offending change set that made an increase or that hurt performance. I recommend you do something similar to that, but I'll leave it to you. As Christian mentioned yesterday, you can use web page tests for this. Sorry, we use our system. There's a blog post about them called Mobile Performance Infrastructure at Facebook. That's a link. You can Google it. You'll get to the same if you want to read about our system. But you can do something pretty similar for yourself with web page tests or other testing tools existing for JavaScript. So we have our goals. We measured, we know how we're doing compared to our goals. Are we better? Are we worse? But then we want to start improving in case we're worse. For instance, if we don't meet our startup time goal, we don't want to improve. So how do we do that? Well, we profile. We profile a lot. So we have two different types of profilers we use. The first one is a sampling profiler, which basically runs your code and tells you where you spend your time. We use Apple's instruments to do that, but I'll talk about web developer tools in a second. And when we ran React Native, we noticed that almost a quarter of a second, which is a lot for us, is being spent on a function with a catchy name JS string create with UTF-8 string. I love this function. When we looked into it, apparently the JavaScript virtual machine expects your JavaScript bundle to be encoded in a certain character type. So every time we load React Native, we spent a quarter of a second just changing our source code and re-encoding it for a different encoding. The obvious thing to do was to just encode the bundle before we ship the app to the encoding that the virtual machine expected, and that way we just reduced this the launch time by a quarter of a second. We found this with this profiler, with this CPU profiler, sampling profiler. And if you're thinking, that's great, so you have the same for in Chrome for JavaScript. For instance, this is the same profiler doing the same thing on 2048, the game. You can do it for your website too and see where you spend time. Another type of profiler is called a marker profiler, which shows you visually and chronologically what happens when you run your code. So we ran a marker profiler on our code, and we got something like this. No worries, I'm going to walk you through it. On the left, you can see different threads and how they execute and what happens there. We notice that we wait for the end of our JavaScript code to start figuring out layouts and rendering views. But when we look closer, we realized that some of the information to render those views is available to us before the JavaScript codes finish executing. And on systems that have multiple cores, which is very common today, we're actually not doing anything in this time, and we have some CPUs, some cores just sitting idle. So we just spread it a little bit more, we made it work in parallel, and we were able to save a lot of time. And this profiler is what enabled us to see it and find that problem. Again, if you like it, you have the exact same thing in Chrome under the profiler tab there in the developer tools, and I recommend you look at it if you're trying to improve your performance. So far we talked about React.js, React Native, the optimization process, how we set goals, measure, and profile where we need to improve. Now I want to talk to you about how we actually improve things, except for the small examples I've just shown. So when we started with React Native, we had some assumptions or some ideas as to how the bridge should work, and I want to walk you through it. So the first one is the bridge is asynchronous, meaning when you call a function on the JavaScript side, your native side does not wait for the result to come back. It calls the function, and it gets an event once the function finished executing, and it can use the function's output or return value. But by not waiting, we actually made the UI thread more responsive because we're not hanging the main thread waiting for a JavaScript call to come back. Next thing about the bridge is that functions called across it are batched. Let me explain that a bit better. So let's say this is function calls, these are calls to JavaScript functions, right? Each function has a slight overhead when we call it, when you send it over the bridge. So to avoid this overhead, or to minimize it as much as possible, we wait for a while, and then we batch functions call and we send them together, making the overhead much smaller. Lastly, data flows across the bridge as JSON. So if we have this native object on the native side, and we want to send it to the JavaScript VM, we turn it into JSON, we feed this JSON to the JavaScript virtual machine, and then it turns this JSON into a JavaScript virtual machine object that it knows and understands. Cool, so this is how things were when we started with React Native. And a year or sometime afterward, we decided we're going to revisit those basic assumptions. Not much we can do about the asynchronous, but let's talk about the batched. Apparently, the overhead was much smaller than we thought it was. So no need, much smaller, yeah, no need to wait too long. And we actually wrote a smarter batching mechanism that waits less time, thus making the app more responsive. The next thing is, you must remember this cool animation, turning object to JSON across the bridge. Well, apparently it takes time. And it takes a lot of time for big objects. So instead, we just taught our native side to take native objects and turn them into the JavaScript virtual machine representation of that object, and then feed it to the JavaScript virtual machine to store it in memory. This saved a lot of time. Sorry, there you go. This saved a lot of time. So these are some of the improvements we've done. But we knew we can do better. We knew we could do much better, and we wanted to find more opportunities. And, as always, when in doubt, profile. So reprofile where the time is being spent. And we noticed that a lot of time is being spent in initializing the JavaScript virtual machine and loading the JavaScript code and executing it. So this was an opportunity ripe for improvement. So we dug into the JavaScript virtual machine. Wasn't easy, but I want to talk to you about it. All right, so the JavaScript virtual machine is a thing that is relevant to pretty much everyone here in the room. This is the part of the system that takes your JavaScript code, interprets it, and executes it. But you guys cannot control which virtual machine you're writing code for. So if your user is using Chrome, it will be Chrome's V8. If she's on an iOS device, it will be Apple's JavaScript core. Or if she's on Firefox, it will be SpiderMonkey. While you cannot choose your virtual machine, we at React Native have the option of choosing a virtual machine and shipping it with React Native itself. So actually, choosing one virtual machine to work with was something we wanted to do because it enabled us to optimize our code for one virtual machine and make it much better. So we needed to choose one. And the one we ended up choosing was JavaScript Core by Apple. So JavaScript Core is developed by Apple. It's part of the WebKit project. It ships with every iDevice, so it's already available on iPhones, iPads, iPods. It has good performance for our needs, actually the best performance of all the virtual machines we've checked for our needs. And it's also open source, which is a major advantage, as we'll see pretty soon. Last thing about JavaScript Core is that it's built for the web and not for React Native. And we noticed it a lot. And I'm going to talk about how we noticed it in a second and where it comes to me. All right, so how does the virtual machine work? Slight warning, that's going to be a bit technical, but not to worry. We have GIFs to help us with this. All right? So the JavaScript virtual machine receives the source code, right? It duplicates it into its own memory. It then does something that is called pre-parsing. Basically, it goes through the source code, makes sure there are no syntax error without even understanding what's going on. Just goes through the code, make sure there's no syntax error, and also gathers some metadata on the functions. It then builds a syntax tree. There's a nice animation there, so I'm going to do it. All right. It then builds a syntax tree, which means it goes through every word in the source code, understands what it does and how it relates to other words in the source code. It then generates bytecode for this syntax tree, no GIF for generating bytecode, and it executes them. Basically, this is the time where your code actually runs. Out of all of these things, the pre-parsing process, much like these minions, is eager, meaning it's being done on all of the source codes you give it to it, not only on the functions you call. So building syntax tree and generating bytecode happens only for the functions you call. But if you have a really bloated bundle or package, pre-parsing will take a long time, even if you call 2 or 3 functions in it. So because JavaScript Core is open source, we were able to measure and see where time is being spent. And apparently, a lot of this time is being spent on parsing. So we thought we'll dig into the pre-parsing process. Got it. All right. So the pre-parsing process, as we said before, it first checks the syntax to see everything's okay and valid, and then it does what we actually call pre-parsing. Basically, it looks for the code, right? It ignores the majority of the content on the functions, and it gathers a lot of data, like where does the function start, how long it is, what variables it uses, what variables it writes. So the next time you want to call say hello, we already know exactly in the source code where it is. We can pull the code and other metadata. Apparently, gathering this information on all of the source code takes a lot of time. Around 10% of the startup time was doing this. And why does JavaScript Core does it every time? Well, I guess this is the nature of the web. You, as a user, encounters or loads hundreds, if not thousands, of JavaScript files every day, right? There's no point in saving this data locally. Also, even if you revisit the same site, JavaScript code can be very dynamic, and there's no reason, again, to cache this data. But for us, in React Native, our source code doesn't change until we update the app, which is every week or a couple of weeks, there's no reason to reparse every time when we load the app. So what we've done is we actually changed JavaScript Core's virtual machines, JavaScript Core's code to, after the first time when you load JavaScript Core and the source code, we take this data, we save it to disk, and the next time you load React Native app, we actually load this cache from disk, put it in memory, and skip this process, which made the load time a bit shorter. And as you can see, the parsing part takes a little less time. But we still spend a lot of time on parsing. This is basically building the syntax tree and generating bytecode. So we went back to look inside the virtual machine, and we noticed that it does the following process. When you call say hello, the function we've just seen, the virtual machine does the following thing. It checks to see if it already generated the bytecode for say hello. If not, it will generate a syntax tree for that function, turn that syntax tree into a bytecode, and store the bytecode in cache. Then it will execute it. The next time you want to execute say hello, the virtual machine will check in its cache to see if it already generated the bytecode for this function, and then it will just execute it. It wasn't easy. It took us a long time. But we were able to modify JavaScript Core code to save the bytecode that was in memory to disk after the first time you load the app. The next time, it will load this bytecode from disk directly into memory, and will always go through the right green path, which made the loading time much shorter. And as you can see, the parsing and the generation part is gone completely. We need to pay a small price to fetch the bytecode from disk and to load into memory, but we're more than happy to pay this price. It's currently experimental, but we're thinking about shipping it on Android pretty soon, where we ship the modified virtual machine. Last thing I want to talk about is random access bundles or random access modules, which sounds like a really big name, but it's actually a pretty simple concept of loading modules upon demand. So let me walk you through it. Your React Native package or bundle or source code contains many features. For instance, let's say you want to use a date picker in your app, right? So we need to include the date picker code inside of the JavaScript source code. But is there a point in loading the date picker code while your app launches? Not really, because you're not going to need it before the app is actually ready. And what if your user is not going to use a date picker in this session of the app? So we created a smarter packager that loads features on demand, meaning when you load the app at the first time, only the features you need now are being loaded, and the rest wait for the first time you're going to use a feature, for instance, a date picker, to load it from disk and into memory. This helps reduce the startup time because we no longer load on startup time features we don't need for that minute, for that moment. And it also reduces memory because features you're not going to use are not being loaded. I want to leave you with the thought of, is it possible on the web? Can we do it? I believe not, but maybe you can convince me otherwise. That's it. I want to sum up with a few takeaways that I love for you to take from here. First off, performance is key for your user satisfaction and engagement. We've done a lot of experiments to confirm exactly that. You should always be measuring. That's what we do. We always measure against our goals to make sure we don't skip and we don't regress. When in doubt, profile. It gives you a lot of information about what's going on. And lastly, don't be afraid to go deep. For us, it was diving into the virtual machine code. For you, it could be the framework you're using or a library you're using. And this is a poster we have everywhere in Facebook. I encourage you to do the same. Oh, yeah. While we can't predict what you'll do to optimize, 4 ideas you should have in mind while trying to optimize is remove unneeded work, parallelizing, caching, and deferring go a long way. Actually, every fix I just mentioned in the talk, without intending to, fell into one of these 4 categories. And there are great ways to save time and improve performance if you need. I encourage you to have a look at the React Native source code and maybe even join its great community. And if you want to learn more, I'll be more than happy to talk to you about it. And you can dive into React Performance, which is a blog post we posted a few months ago describing what I just said and a little bit more. And you can read the performance section in the React Native site. This talk, everything I mentioned was the work of the React Native and React Native performance teams in London and in MPK, and I want to thank them for their work. And I want to thank you for listening. So thank you.